October 7th, 2008. Qantas Flight 72, an Airbus A330 with 315 people on board, is en route from Singapore's Changi Airport to Perth, Australia. 3 hours into the flight, while still over the Indian Ocean, the captain returns to the cockpit after his break, and the first officer exits the cockpit for his break, leaving the captain and second officer flying the plane. Without explanation, the autopilot disengages and a slew of errors appear on the pilot's screens. The crew is reviewing the errors when the plane suddenly and violently pitches down towards the ocean below. The captain pulls back on his side stick, but the plane refuses to respond. The plane eventually levels off, but then dives again. What is happening to Qantas Flight 72? Is the crew able to successfully recover the plane? Find out on this episode of Black Box Down. Hello everyone, welcome to Black Box Down. It's Chris and Gus. Hello, Chris.
Hi, I like Qantas. They have good food.
Is that why you like them? You think they have good food?
They did. I think out of all the air overnight flights, they have the best food. Anyway,
I think Rain Man also really liked Qantas.
Who?
Is that Rain Man? Is that too old of a reference?
I know Rain Man, the movie. I just don't remember that.
What he says is he wants to fly Qantas because they've never had an accident.
Oh, is that a spoiler? I guess that's an old movie. That movie was before this flight.
The 80s, yeah. Do you know what Qantas stands for? No, we're on a tangent now, a little bit of trivia.
No.
Queensland and Northern Territory Aerial Service.
Okay. I was going to say it's probably something Australian.
Mm-hmm. Yeah, you're right. So we're here. We're going to be talking about Qantas Flight 72. This is a more, amongst the incidents we talk about, more recent, October 2008. I remember when this happened. So it's. I feel like this, may be a little more recent. Other people might remember it as well. So Qantas Flight 72 was a passenger flight from Singapore Changi Airport to Perth, Australia. The flight was crewed by Captain Kevin Sullivan, who was 53 years old and had 13,592 flight hours. First Officer Peter Lipset, who had 11,650 hours, and Second Officer Ross Hales, who had 2,070 hours. The aircraft, like I said, was an Airbus A330 with 20,040 hours and 3,740 cycles. There were 303 passengers and 9 flight attendants on board as well, for a total of 315 people, like we said earlier. So Flight 72 took off from Singapore at 9:32 a.m. local time and climbed to the cruising altitude of flight level 370, with the autopilot maintaining their altitude and the auto thrust maintaining a cruise speed of Mach 0.82, so 0.82 times the speed of sound, which is a pretty typical cruising speed.
0.82 times the speed of sound?
Yeah.
I didn't know it went that fast.
Yeah, you go pretty fast in modern planes. At 12:33, the captain returned to the flight deck after his break, and then 6 minutes later, the first officer took his break, leaving the second officer in the right seat. At 12:40, one of the aircraft's 3 air data inertial reference units started providing incorrect data to the other systems. That's a mouthful, by the way. Air data inertial reference unit. That's referred to by an acronym as the ADIRU. So if you hear me say ADIRU, it's the Air Data Inertial Reference Unit. It's basically just like a computer that's in the plane that processes and feeds a lot of the data to the autopilot and to the flight deck, so that's what shows their airspeed, their angle of attack, all of the stuff on their instruments is processed through the ADIRU.
Okay.
And also there's just, I guess, to explain this a little more, it's a computer, like I said, it processes airspeed, angle of attack, altitude data, inertial reference, which is like position and altitude. And just for your reference, there's 3 ADIRUs on a plane.
That was my next question. I was like, is there, there's probably more than one, huh?
Yes. So from what I understand, the way it works is ADIRU 1 feeds all the data for the left seat, the captain's seat.
Okay.
ADIRU 2 feeds all the data for the right seat, typically the first officer. ADIRU 3 is a backup that can either be switched on to replace ADIRU 1 or ADIRU 2 if they fail.
All right.
So ADIRU 1 and 2 do not talk to each other from my understanding, but ADIRU 3 is able to step in if either of 1 or 2 fail.
2 independent systems and a backup.
Oh yeah, that's a good way to think about it. Yeah, 2 independent systems and a backup. That's a great explanation, Chris. And I don't know if I mentioned it, it also sends all of that information to, like I said, the autopilot, the flight control systems, landing gear, just about everything, all of the computer control systems. So when this happened and when the ADIRU started providing incorrect information, the autopilot disconnected. And then 5 seconds later, a series of caution messages began appearing on the ECAM, which is the Electronic Centralized Aircraft Monitoring. It's one of the computer displays in the cockpit.
Okay.
And all of these caution messages were accompanied by a master caution chime. So they're starting to get a lot of errors, and then, the audible alarms are going off as well. The crew also started receiving audible stall warnings and overspeed warnings, which, doesn't make sense. I don't think you can be stalling and overspeed. I mean, that would be really weird, right?
Yeah, you'd have to be
going
pitching
really
up
fast,
a lot.
really pitched up. It's kind of counterintuitive. It's just like it doesn't make sense. It's just one of those you look at like, how is that possible?
Yeah.
And there would be brief warnings, but they just continued to chime intermittently for the remainder of the flight. The crew then noticed one error code which said nav1 IR fault, which indicated a fault with the inertial reference part of the Ataru 1. In addition to all of these warnings, the airspeed and altitude indicators on the captain's PFD were fluctuating. PFD is primary flight display, by the way. The right seat PFD and the standby instruments were acting normally, so the captain used those while he was flying. So again, like I said, remember, Ataru 1 feeds all the data for the captains, and Ataru 2 feeds it all for the first officer. So everything on the left side of the plane's broken. There's an error saying Ataru 1 might be messed up, so they're having to use all the readings from Ataru 2 on the other seat.
And do they just swap it to the backup? Which one is the plane using? Does that make sense?
The plane's not sure what is going on exactly, right? That's why autopilot disconnects.
Okay.
It knows that it's receiving weird data.
Conflicting.
Right. So number one, or Ataru 1's giving really weird readings. Ataru 2 is normal. They've not done any switchover or failover to Ataru 3 at this point. So Ataru 3 is just still in standby mode.
Okay.
Although there were several ECAM caution messages, none of them required urgent action, and none of them indicated any potential problems with the aircraft's flight control system. However, the captain was not satisfied with the information that the aircraft systems were providing, and he asked the second officer to call the first officer back to the flight deck to help them diagnose and manage the problems. And the first officer had only been gone for about 3 minutes at this point. And I'm sure, he's thinking like, oh, great, as soon as my break starts, gotta go back in, gotta get back to work. At 12:42, the second officer was asking the cabin services manager to send the first officer back to the flight deck. And while he was doing this, the aircraft abruptly pitched nose down. The pitch down was caused by a sudden change in the elevators, and the maximum nose down pitch angle reached 8.4 degrees. So, they're like, oh, this is weird. Our instruments are giving us strange readings. And then all of a sudden the plane just like pitches straight, or not straight down, but 8.4 degrees down. The captain immediately applied back pressure on his side stick. And at first, the flight control system did not respond to the input. But after about 2 seconds, the aircraft responded normally and the captain recovered to the assigned altitude. So that's got to be pretty terrifying. The plane's pitching down. The captain, immediately pulls back to give back pressure, and the airplane doesn't respond at all. I believe in interviews he said he pulled back, nothing was happening. Then he released, let it go back to neutral, and then pulled back a second time, and then that's when it started finally responding.
Ugh.
The aircraft had descended 690 feet over 23 seconds before returning back to flight level 370 and had a vertical acceleration of negative 0.8 Gs. So do you know what that means when their vertical acceleration has negative Gs?
Does that mean, it's still G-force, but it's the other direction?
Right. It's G-force up.
So you're being pulled up?
Right. Anybody who's not wearing their seatbelt or not strapped in slams into the ceiling of the plane.
Oh.
It's not a full 1G. It's like 0.8 of your body weight, but pushing you up towards the ceiling.
Oh, is that what it stands for? Like your body weight?
Well, your body weight is your body weight at 1G, because we're used to 1G. So, 1G, you weigh whatever you weigh on Earth, obviously. 0.8 G would be 0.8 of your body weight up, or 0.8 of gravity up. So that works out to about 0.8 of your body weight.
Huh. I never knew how. So it's like your body weight is the one?
So your body weight is your body weight when you have 1 unit of gravity expressed on it or acting on it. That's the way to think about it. It's like Earth has 1 G of gravity. That's what we're all used to.
Gus, I just realized that gravity force.
Yeah.
I never.
That's why when people they talk about other planets or the moon, if they say it's got 0.3 G there, you only weigh 0.3 of what you normally weigh on Earth because there's 0.3 gravity. So you learned something today. See, the podcast did something positive. Educational. So this is terrible, because if you're standing in the plane or you're sitting down and not wearing your seatbelt, all of a sudden, the plane dives, you hit the ceiling.
Yeah, and this was out of nowhere, so they probably had they didn't have the fasten seatbelt warning on?
They were at cruising altitude, so the seatbelt sign was most likely off at this point. So the lesson here is always wear your seatbelt if you're sitting down on the plane. Personally, I always keep my seatbelt on. It's only if I'm getting up to go to the bathroom and then right back down with the seatbelt on.
Well, I do now.
Trust me, after you see the photos we post on social media of this, you will wear your seatbelt as well.
Oh.
People hit the ceiling of this plane so violently that some of the panels cracked and have holes in them.
Oh.
Yeah, they were just thrown around in the cabin and injured, because they hit everything overhead. At this point, the second officer activates the seatbelt sign.
Yeah.
You may have noticed we encountered some turbulence there. Yeah, and he makes a call on the PA for the passengers and crew to return to their seats and fasten their seatbelts.
He just said it was turbulence?
Well, that was me speculating.
Oh,
I'm sure he didn't say that. I'm sure he just said, go back to your seat, put your seatbelt on. So this upset happened while the aircraft was over the Indian Ocean, about 154 kilometers west of Learmonth, which is in Western Australia. At 12:45, while the crew was responding to the ECAM messages, the aircraft pitched down a second time, reaching a pitch angle of 3.5 degrees nose down. This was similar to the first one, just not as severe. I said, the first one was 8.4 degrees, this is 3.5. Again, the captain immediately applies back pressure on his side stick, but like the first time, again, it took 2 seconds for the aircraft to begin to respond.
That's a long time in flight, 2 seconds.
Especially when you're watching the plane just like nosing down and you're pulling back. They should be doing something. So this time the aircraft descended 400 feet over 15 seconds. As the crew was going through their ECAM messages, new caution messages kept being placed at the top of the list. The nav IR1 fault message kept recurring with other messages, and they could not effectively interact with the ECAM to action and or clear the messages. The report notes that the master caution chimes associated with frequently occurring ECAM messages together with the aural stall warnings and overspeed warnings could not be silenced, and they were a significant source of distraction to the crew. So they're trying to troubleshoot everything, and all these audio warnings are going off, these chimes, stall, overspeed, and
all at once.
All at once, and they're just trying to make sure the plane keeps flying and troubleshoot and figure out what's going on. At 12:46, the second officer asked the flight attendant to send the first officer to the flight deck again. A minute later, the captain disconnected the auto thrust to minimize any potential problems associated with the erroneous air data information affecting the electronic engine control units. He flew the aircraft without autopilot or auto thrust using his standby instruments for the remainder of the flight. Moments later, the first officer returned to the flight deck and sat in the right seat, putting the second officer in the jump seat, and informed the crew that there were some serious injuries in the cabin.
Oof.
The crew decided they needed to land as soon as possible due to concerns that the airplane would pitch down again. And they decided that Learmonth would be the best place to land, and about 12:49, the first officer made a pan broadcast to ATC stating they had some flight control computer problems and that some of the occupants were injured. They were cleared to flight level 350, and the captain asked the second officer to go to the cabin to get more information about the extent of the injuries. At 12:51, the flight was cleared direct to Learmonth. The second officer reported there were several serious injuries in the cabin, and the crew declared a mayday. So, they know they need to get down as quickly as possible. Mm-hmm. One, because the plane is behaving unexpectedly, and two, because people are seriously injured and need help.
Yeah.
Like I said, they declared a mayday. They're landing in Learmonth, and that doesn't necessarily mean that they're out of the woods. I tried to look this up, and there's an Air Force base there in Learmonth, and it says that it's near the town of Exmouth, Western Australia, and that town has a population of 2,486. These aren't very big cities that they're flying towards. So just because, they're going to be landing doesn't necessarily mean that these people are going to be out of the woods, because they're landing, in kind of a small remote area.
Yeah, and they don't really have a way to get, there's probably not a full crew.
Or there might not be a big hospital.
Oh, yeah. I didn't even think about that.
That would be my concern, is they might not have the facilities to take care of everyone once they land. So during the diversion, the warnings for nav IR1 fault, and I don't know how to pronounce this. This is like an error code, so I'm just going to read it. F/CTL prim 3 fault. It's a warning for the flight control primary computer 3. So I guess it's flight control primary 3 fault kept occurring, and the crew basically determined that the ECAM was useless at this point, because now they don't know what they can trust. They don't even know if these error messages are real or if there's even any point in trying to troubleshoot them. At 12:56, the first officer contacted the maintenance watch unit for Qantas by satellite phone to seek assistance. Maintenance watch advised the flight crew that Aoa 1 appeared to be common to the fault messages being displayed, but there were also some conflicting information regarding elevator control.
Who said that?
Qantas maintenance.
So they get the plane's data during the flight?
Well, at this point, the first officer had called them by satellite phone.
Okay. And so it's like connected to their...
Well, they were, I'm sure the first officer called and started telling them what all the error messages were that they were receiving. And, after he reads it all, it's the thing you don't want to hear when you call tech support. So he calls tech support, reads them all the error messages, and they say, yeah, we don't know. The maintenance had no recommended action at that time.
Okay. That's the worst.
Except this is even worse than, I call tech support and my internet's out. I'm annoyed. You're in a plane that's not flying right and you call tech support. It's like, oh, I hope we don't crash.
Yeah.
So in a subsequent discussion, Maintenance Watch recommended that, at the crew's discretion, they could select Prim 3 off, to shut down Flight Control Primary Computer 3. They turned this computer off, but it had no effect on the scrolling ECAM messages, stall warnings, or overspeed warnings. So it didn't really seem to have any effect on all the warnings they were getting.
Oh, so they turned the one off entirely?
Prim 3, which is the Flight Control Primary Computer 3.
Okay, the third one.
That's not the Adaru. It's a different.
Okay, sorry. I was thinking of okay.
So the crew faced several other problems during the diversion. They were unable to enter an RNAV approach into the flight management computer due to the fault messages associated with the GPS unit. And then on top of that, the second officer had to manually control the cabin pressure during the descent due to a pressurization system fault.
What?
Right. It's like all of their systems are really starting to mess up, and they're having to, all the things that should be happening automatically, they're having to keep an eye on and take care of. Like, who would think, we should make sure the cabin has pressure?
Yeah.
Right. These are things that you kind of, I guess, take for granted.
I didn't even know that was a thing that was controlled, could be manually controlled. I don't know. I never even thought about cabin pressure. Is there a knob?
I don't know. I presume there probably is. Cabin pressure is typically fed by, I don't know if we've talked about this before, it's typically fed by bleed air from the engine. So, the turbines are taking in all this air, then, it can divert some of that into the cabin to provide pressurization. So I'm sure they're probably just adjusting the bleed air manually coming in from the engines. I assume that's what's going on. I don't know. I'm not a pilot. And on top of that, I've never flown an A330. So I can't answer that for certain. So the crew also noted they would need to use manual braking during landing due to an auto brake fault. So their auto brake's not working, so they're going to have to hit the brakes themselves.
Yeah, it sounds like they should just go full manual at everything.
They were also fortunate because the pilot for this flight, he was a retired U.S. Navy pilot. So he'd flown planes for the Navy here in the United States. He was actually worried when they were coming in that once, they get low to the ground, he was worried that the plane was going to pitch down again, and that once they're at a low altitude, there wouldn't be enough time to recover, especially if there's a 2-second delay for his inputs to nose back up.
Yeah, that's super scary.
He did a special kind of landing that they use in the military that you typically don't do in civilian passenger planes. He wanted to try to keep as much airspeed as possible so that, even though he didn't have altitude, he had airspeed, and maybe that would give him enough. He was a bit of a trade-off to try to correct the plane in case it nosed down. So instead of coming in, on that long, final approach where you slowly descend and land, he basically flew over the airport and then did a corkscrew down onto the runway.
What?
Yeah, so he came over the airport and then did a really tight turn to corkscrew down. That way he could maintain as much speed as he could. And then at the last second, try to get rid of that speed, hit the ground, and then apply as much brakes as he could.
Okay, that's really badass, though. That's super...
Right, that's a military maneuver. That's not something you do in a passenger plane. But again, he's trying to think, if this happens again, if if the plane noses down, what are we going to do? How can we try to mitigate this? And this is the solution he comes up with to try to keep the plane as stable as possible.
That's so cool, though. Sorry, I'm going to have to go military.
I would not want to have been on that plane, by the way. I can't imagine as a passenger, because the plane had already nosed down, and then you start doing this spiral over the airport. I can't imagine what they were thinking in the back of the plane at this point.
Yeah, because the pilot knew what he was doing, but man, that's scary. If you're just
yeah. So the flight did land at Learmonth at 1:32 p.m. There were 12 serious injuries and 107 minor injuries with no fatalities. The only damage to the aircraft was the overhead fittings that were consistent with passengers or crew members being thrown around the cabin during the first nose down upset. So that's, if you think about it, that's crazy. The only damage the plane suffered was from people hitting the inside of the plane when it nosed down.
Yeah, humans are the only... God.
Yeah, that just gives you an idea of how violently people hit the ceiling in the plane. And again, I'll post some of these pictures on social media if you follow us at Black Box Down Pod. It's crazy. There are holes in the ceiling from people hitting it. I can't imagine how much that must have hurt.
Yeah.
So the investigation was carried out by the ATSB, which is the Australian Transportation Safety Bureau. They wanted to take a look at the ADARUs in this aircraft. The aircraft's 3 ADARUs were removed to download the unit's built-in test equipment data. The built-in test equipment data from ADARU 1 showed no fault messages from the occurrence of the flight, which is not what you want to hear.
No.
It was clearly messing up, and it's like, no, I'm good. No errors, no problems here.
It's all good here. Yeah,
Yeah, no problems at all. By the way, this is an acronym, the built-in test equipment. The acronym is BITE. So here we talk about BITE, that's built-in test equipment.
Okay.
So like I said, the BITE data showed no fault messages for ADARU 1. Given the fault messages recorded by other systems related to ADARU 1, some fault messages should have been recorded.
Yeah.
The way I can think about it is like when you're out drinking with your friends and you have that one friend who's really drunk and he's like, no, I'm good. And everyone else around like, no, he's not, that guy's messed up. That guy's not good.
That's a really good analogy.
He's like, no, I'm good. I'm fine. I'm good. No. Like all the other systems are pointing at ADARU 1 saying, no, the ADARU 1 is not good right now.
ADARU 1's drunk.
Yeah. In addition, several routine messages normally stored in byte memory were either not recorded or had anomalies. And I'm going to read through some of them right here. An alignment record should have been recorded after the ADARU was turned on in Singapore, and it was not recorded. A routine nav update record should have been recorded when the unit was shut down at Learmonth. It was not recorded. Routine elapsed time interval timestamps should have been recorded during the flight. The ADARUs were on for 14.8 hours before being shut down at 3:25 p.m. However, the elapsed time interval observed at turn on at the manufacturer's test facility was about 0.7 hours after takeoff. So, like, timestamps are wrong, which is like very fundamental and basic. Routine temperature records should have been recorded every hour. None were recorded after the start of the event. So that's like seemingly benign and innocuous, but still like that's data that should be there.
And it's what they need to figure out what went wrong, right?
Well, I mean, the temperature, I don't think they necessarily need to know that to know what went wrong, but it's just like an indication. Like clearly there's something wrong. It's not recording the things it should be recording, but at the same time, it's saying it's not having any issues.
Yeah.
Want to learn a box like Muhammad Ali? Okay, maybe not quite heavyweight legend level, but like maybe your own best inner boxer? Well, Fight Camp brings the boxing and kickboxing gym to you with full body workouts that you'll actually enjoy and actually do. Fight Camp's for everyone from kids to adult beginners to experienced boxers. They've got multiple learning tracks on an app that teaches you boxing skills plus training workouts. You'll get to learn from experienced fighters ranging from MMA pros to kickboxing champions. And Fight Camp comes with all the necessary gear to box at home, including a freestanding punching bag, boxing gloves, quick hand wraps, and even punch tracking sensors that let you track your boxing and kickboxing progress. I'll admit, I was a little intimidated about this one. I got all the stuff, wasn't sure what I was getting into, thought it was going to be overwhelming. I've never done anything like this in my life, but it was all super easy to set up. It's all super easy to use. The app's great. I can't say enough good things about how easy it is to get going and to actually, get some work done, actually feel like you're making progress. It's great. You can pay for your Fight Camp over 24 months for less than the cost of a boxing gym, and you get it right away. Plus, Fight Camp offers free shipping with a 30-day money-back guarantee. Just go to joinfightcamp.com/blackboxdown to get free shipping on Fight Camp. Go to joinfightcamp.com/blackboxdown. Joinfightcamp.com/blackboxdown. I know everyone, including me, is guilty of agreeing to listen to whatever podcast someone recommends, and then you never actually get around to it. Definitely don't let that happen here because you'll want to give the Jordan Harbinger Show a listen. Each episode is a conversation with a different, fascinating guest. There's something for everyone, and I mean everyone. In one episode, Jordan talks to a hostage negotiator from the FBI who discusses techniques on getting people to like and trust you. Disturbing, but maybe also kind of useful. In another episode, we hear from a cinematographer who discovered a lost city in a jungle and made one of the most important archaeological finds of the century, like a real-life Indiana Jones movie. I recommend our listeners check out Jordan's conversations with there's tons of them. Mark Cuban, Matthew McConaughey, Kobe Bryant, T-Pain. There's a bunch of really great ones out there. I really enjoy the show. I think you will as well. There's just so much here. Check out jordanharbinger.com/start for some episode recommendations or search for The Jordan Harbinger Show. That's HARBINGER on Apple Podcasts, Spotify, or wherever you listen to podcasts. Everyone loves ordering stuff from the comfort of their PJs, but we all face doubt when we see that promo code field taunting us as we check out. If only we had the magic code to save 15%. That's why there's Honey. Honey is the online shopping tool that scours the internet for promo codes and saves you money all for free. Honey applies the best codes it finds right to your cart. You just add it as a browser extension, and when you check out online, Honey pops down. All you do is click Apply Coupons. Whatever it finds, it auto-applies to your cart. I Can't stress how easy it is. Sometimes I forget that I even have it there. I was buying some clothes recently, was checking out, and they just popped in, saved me money instantly. I forgot it was there, and I didn't have to do anything. Well, I guess I had to click, but I made like a click or two, and saving money. It's great. So if you don't already have Honey, you could be straight up missing out on free savings. It's literally free, installs in a few seconds. By getting it, you'll be doing yourself a solid and supporting this podcast. I never recommend something I don't use. Get Honey for free at joinhoney.com/blackboxdown. That's joinhoney.com/blackboxdown. So after looking into the Adaroo more, the ATSB saw that the Adaroo outputted numerous spikes on air data reference parameters. The spikes were short, with less than 1 second of duration, and they occurred at different times and frequencies for each parameter. With the exception of these spikes, all the air data reference output data seemed to be correct. The Adaroo also outputted numerous spikes on inertial reference parameters with similar characteristics. This generated an inertial reference caution message, but not an air data reference message. So they're looking at all the data, it's processing and outputting, and there's like weird spikes in it every so often that are really short, but still there's spikes that are not consistent with what should be happening on this flight.
Mm-hmm.
The main problem associated with this failure of the Adaroo was that the air data reference spikes were not flagged as invalid and went undetected by the Adaroo. So normally, if you get bad data, it should recognize it like, oh, well, that's just an anomaly. That's just bad data. Chuck it. But instead, the Adaroo's processing these spikes and this erroneous data, and it's not flagging these as invalid. So it's passing it on as valid data to the rest of the systems. So since this data is coming through and is not marked as bad, they believe it's good because unless they're told it's bad, why would they assume it's bad?
Mm-hmm.
So they're getting these weird data spikes coming through. So one of the spikes that the Adaroo was giving out was for angle of attack. An angle of attack is just the angle that the plane is either pitched up or pitched down relative to the wind, or the angle of your wings going through the wind, whether up or down.
Okay. Not like the way the wind is blowing, but like the way it's hitting the air.
The way it's hitting the wing.
Yeah. Okay.
So this information was being sent to the electrical flight control system's flight control primary computers. The airplane's elevators were being commanded by the flight control primary computers. The flight control primary computers were designed to command a pitch down if they detect that the aircraft's angle of attack was too high. So again, this is one of those safety measures like we've talked about before. If the flight control primary computer detects angle of attack is too high, it pitches the plane down to kind of keep it safe, to keep it from stalling.
And that's what it was causing it to jump, or not jump, but
right.
Yeah.
So if it's getting weird spikes, like invalid angle of attack data showing that it's really spiked up, then it's going to probably want to respond by trying to pitch down.
Mm-hmm.
So they go ahead and they review there's an acronym here. I'm just going to start saying it. So the flight control primary computer, the acronym is FCPC. So they review the flight control primary computer's algorithm for processing angle of attack data, and they identified a very specific scenario in which incorrect angle of attack data from only one of the aircraft's 3 Adaroos could trigger a pitch down command. This goes to your earlier question about which Adaroo and which computer is the plane listening to. I didn't want to spoil it then. I was kind of waiting until we got to this point. So the scenario that they found required 2 angle of attack spikes, with the second being present 1.2 seconds after the start of the first. 2 minutes before the first pitch down, Adaroo 1 started outputting spikes in angle of attack data, and the spikes were present at the time of both pitch downs. So Adaroo 1's spitting out bad data, this bad angle of attack data, the flight control primary computer seeing it, it's not flagged as invalid, so it thinks it's valid data, so it triggers the safety to pitch the plane down, which is what they're trying to fight here, which is similar to what we talked about with the 737 MAX 8 with the MCAS data, but it's a different issue, but kind of similar, where there's bad data being fed to the computer, so it's pitching the plane down.
And this is just the computer, not the devices that collect the data.
Right. The data is being fed correctly, and you know that because Adaroo 2 and Adaroo 3 were processing it correctly. Adaroo 1, just for some reason, is getting the same data as the other Adaroos, and it's just processing it incorrectly, and as a result, spitting out bad data that's getting ingested into the computer that then is being acted on. Like we said, Adaroo 1's had a few too many. So aircraft systems are designed with the expectation that technical faults will occasionally occur. Accordingly, the aircraft had 3 Adaroos to provide redundancy and fault tolerance. Using the median of 3 values for a parameter as the system input is common and generally robust algorithm, and the A330 used this approach for most parameters. So again, this goes to your earlier question about what is it listening to? typically, lots of times it'll use, a median value across 3 systems, which if they're all working properly should be identical or really close to each other.
Yeah.
However, in order to address aerodynamic issues associated with the locations of the 3 AOA sensors, the FCPC based the system input on the average value of AOA 1 and AOA 2. AOA, of course, is angle of attack. Nevertheless, they still used all 3 AOA values to check for consistency as a basis for filtering out deviating values of AOA 1 and AOA 2 for triggering a 1.2 second memorization period using the previous value if an errant value of AOA 1 or AOA 2 was detected. So you can kind of summarize this all. The angle of attack sensors are in different parts of the plane. So as a result, they may have slight deviations in what they're feeding into the computer. This is all just kind of trying to figure out how to account for that and how to normalize the values so that you're getting consistent data fed into the computers.
So, and I want to see if I understood or heard you correctly. So the way it is it's the 3 computers. They all have different sensors, different places, but it's taking only 2 of the computers and averaging those 2 computers. And then the third one still, though, used as like a reference point.
Well, yes, except replace computer with AOA sensor. So here we're talking specifically about the angle of attack sensors, which are the sensors on the outside of the plane.
Okay.
So there are 3 angle of attack sensors on the plane, but they're in different locations, so they might have slightly different values. So that's why it's looking primarily at AOA 1 and AOA 2 because they're the same. AOA 3 is a little different. So that's why it's using AOA 1 and AOA 2 and using a median value from their sensors to then feed that into the ADARUs.
And if it's a median between the 2 of them, and one of them is really wacky, that could have caused it?
Right. So if and we're talking again here specifically about the AOA sensors, if they are triggered and then triggered again 1.2 seconds later, then it assumes that the value is probably correct. And this is in the computer's algorithm when it's processing the data that it's receiving.
Okay, so it's like written as coded to be like, okay, if this happens for like over a period of 2 seconds.
1.2 seconds. Yeah.
1.2 seconds. And then that's why it took so long to respond to his controls?
Maybe. I can't speak to that specifically. It's possible, but I can't say. That's an extremely technical question that I bet you would need someone who programs the A330 processing to be able to answer that, or like an NTSB investigator to answer that for you. All this is to say that this algorithm that was written did not effectively handle the transition from the end of a memorization period back to normal operating mode when a second data spike was present. So they basically just found like a loophole in the logic, in the programming for the way the angle of attack sensors are read, where if it was triggered with bad data and then another piece of bad data came in before the first one was cleared out, then it assumed that the data was good and that there was a really bad angle of attack that needed to be corrected. It's just this really weird, bizarre scenario, which should not have happened, but because the data was not being properly processed by the ADARU, it did get triggered.
Yeah.
A series of analysis determined that the failure almost certainly occurred within the ADARU's CPU module. So it's like the processor, the brain, the CPU is like the central processing unit. It's like the main part of the computer that does all the math. So more specifically, evidence indicated that many of the data spikes for air data reference parameters were produced when the CPU module packaged the 32 output data words. These data spikes were found to be the result of the data word being packaged with either the wrong label field or the wrong data field. So it was bringing in all of this data, and then for some reason, it was swapping some of the labeling for some of the data. Specifically, I think that it was swapping angle of attack data and labeling it as altitude data, and it was taking altitude data and labeling it as angle of attack data, which is why everything was spiked, because all of a sudden things were mislabeled. It was fed to the next computer, and the numbers were way off from where it was before because it was all mislabeled.
That's wacky. That's so wacky. I didn't know, how, and it just started doing it randomly.
Right. Just like out of the blue, it just started happening. And on top of that, like I said, or like you said, it was intermittent. It wasn't like it was consistently doing this. It was just like all of a sudden, every now and then, like it would just swap them. In addition, it was very unlikely that each data spike was due to a separate fault, failure, or trigger event. The data packaging process involves several components within the CPU module, including the CPU chip, application-specific integrated circuit, a wait-state RAM chip, and for RAM chips for general CPU use, but the investigation could not identify which of these components were directly involved. We're not even saying broadly, the computer messed up. We're saying very specifically, these chips in the computer were just mislabeling data for some reason with no seeming pattern to it, just randomly and intermittently.
Yeah, that's really, I don't know a ton about computers, but that just doesn't make sense, like in my brain. Like that.
Right. At this point, we're not even talking about like a programming or a coding problem. The hardware is not running the program correctly.
And randomly and sporadically. Was it like, if it was like overheating or something?
That's a good question. Overheating can lead to this. Part of the testing that they did for this was they took the Adaroo and they wrapped it like in a thermal blanket and made it do a bunch of stuff to run it at a really high temperature. And it didn't seem like that caused it. It didn't seem like it was an overheating issue. But yeah, if I was working on my computer, it'd be the first thing I'd think of too. I can't even begin to think of an analogy for using your computer. I don't know. It'd be like if you tried to like launch Chrome and your computer shut down instead. And your computer was like, no, that's what you wanted to do.
No, it'd be like launching Chrome and then it opens like Photoshop.
Right, yeah.
What?
Like,
what?
The totally different thing happens that you're not expecting. So some of the possible triggers for this failure could have been software bugs, software corruption, hardware fault, some sort of physical environment factors like temperature or vibrations. You mentioned temperature. Or other aircraft systems. However, the ATSB finds these to be unlikely based on evidence, which includes Adaroo testing and an absence of evidence of the existence of the trigger event. The other trigger type considered was a single event effect. The CPU modules did not have error detection and correction, which decreased their resilience to single event effects. However, it was very unlikely that single event effects could occur at the same location within the same unit and produce the same effect without also occurring on many other units of the same type. But susceptibility to single event effect can vary significantly between components with the same part number, and there may have been more than one location that could produce the same effect from an SEE. Overall, the probability that failure mode was triggered by SEE could not be reliably estimated without knowing the exact mechanism involved in the failure mode, or by demonstrating the failure mode could occur during testing the affected units. It was unfortunately not practical for the investigation to test the units at an appropriate facility. So they really are left scratching their head here. They can't figure out what would cause this. There's an explanation. There's like I don't want to say a conspiracy, but there's some people who believe they have an idea for what will cause this. And this is not in the investigation. This is other people who think that this is a possibility. I'm only going to touch on this lightly because I don't want to give this too much credence. Yeah. It's a little too speculative for me. Some people speculate that this failure was caused by high energy particles that were generated by cosmic rays that were hitting the Earth right at that exact moment, right at that exact time.
What?
What? So, in space, in the universe, there's these cosmic rays that are always flying around. They say that it's not very well understood. It's possible that cosmic rays were flying through this spot right at the exact point and hit, and these cosmic rays go through the plane and hit the Adaroo right at that exact moment and start causing this error.
Cosmic rays? What does that mean?
It's like background cosmic radiation that just exists and is everywhere in space. Like you think about the northern lights, like those are like cosmic rays hitting the atmosphere.
Okay.
So just like these rays, like from a solar wind, could have hit the Earth, come through the magnetic field and hit this plane. There's no way to test for that. There's no way to know that for certain. But this is just one of those things where it's like, this is such a wacky occurrence that people are starting to wonder, what other out of left field things can we possibly say could have potentially caused this? Personally, I do not believe the cosmic ray explanation. And I'm going to get into why I don't believe it in a bit. I'm going to read through the official reports contributing safety factors here. We'll talk a little more of stuff about the official report, and then I'm going to tell you why I don't think that cosmic rays caused it, okay?
Okay.
So the contributing safety factors in the report. There was a limitation in the algorithm used by the A330 flight control primary computers for processing angle of attack data. This limitation meant that in a very specific situation, multiple AOA spikes from only one of the three air data inertial reference units could result in a nose-down elevator command. This is just the flaw in the algorithm we talked about earlier. When developing the A330, A340 flight control primary computer software in the early 1990s, the aircraft's manufacturer's system safety assessment and other development processes did not fully consider the potential effects of frequent spikes in the data from an air data inertial reference unit. So again, just kind of blaming it on the coding could have been maybe a little more robust to prevent this.
Okay. Yeah, sure.
Right. One of the aircraft's three air data inertial reference units exhibited a data spike failure mode during which it transmitted a significant amount of incorrect data on air data parameters to other aircraft systems without flagging that this data was invalid. The invalid data included frequent spikes in angle of attack data, including the 7th October 2008 occurrence. There have been 3 occurrences of the same failure mode on LTN 101 Ataroos, all in A330 aircraft. This is why I don't believe the cosmic ray. I'm going to get into it right now. The fact that they said that there have been 3 other occurrences of the same failure mode makes me think that it's a recurring problem. It's not some wild cosmic ray. And more specifically, a couple of months after this, on the 27th of December 2008, Qantas Flight 71, flying from Perth to Singapore, had the exact same thing happen to it west of the Australian coast. That crew remembered this incident we're talking about, and they were able to counteract it and continue their flight just fine.
Counteract it, like as in like just swap the Ataroos?
We haven't gotten to it yet, but there's a revised procedure that was released as a result of this, warning crews, if you encounter this problem, here are steps to bypass it. This other crew performed the revised procedure that Airbus had released, and they actually returned to Perth uneventfully. So they were able to regain control of the plane because of findings from the incident that we're talking about. So that's why I kind of don't believe the cosmic ray thing. Although the people who believe in cosmic rays are going to say, don't you think it's weird that both of these failures happened west of Perth off the western coast of Australia? To which I would reply, well, Qantas is an Australian airline. Most of their flights are going to be around Australia.
Yeah, but it's only that plane?
It's only A330s, and it's always in the same area, kind of west of Australia. God, I mean, there's other conspiracy theories. I'm not going to get into them too much. Like I said, there's a military base there in Learmonth. There's also speculation that maybe there's some kind of military radio or some kind of military technology that's being activated in this area that's causing this error.
Some sort of secret
weapon. Top secret thing that we don't know about.
Yeah.
We don't know. The investigators flew this they took this specific Qantas 72 flight. They took it back into the air west where the failure occurred, and they flew it around trying to recreate it to see if they could make it happen again. And they took a bunch of instruments to detect electromagnetic frequencies, and they couldn't detect anything.
And it was the exact same plane.
It was the exact same plane in the exact same location. So I can't say. We don't know. Maybe there's some top secret stuff going on, but they weren't able to recreate anything. Anyway, okay, I got off. Go back to the contributing safety factors. I got on a little tangent there. The LTN 101 Air Data Inertial Reference Unit involved in the occurrence also had a previous instance of data spike failure mode, indicating that it probably contained a marginal weakness in its hardware, which reduced the resilience of the unit to some form of triggering the event. So, it had acted up before. Maybe this was just a faulty CPU that had some manufacturing defect. Maybe there was like a batch of these CPUs from the manufacturer that had a fault in them. It's not uncommon. When you buy a computer, right? Or like, let's say, I'm going to try to keep this very broad and very simple. So you buy a computer, and one of the ways people measure computing power is like CPU speed, right? I'm sure you've heard that before. This computer is 4 gigahertz. This computer is 3 gigahertz. This one's 2.8. Lots of times, all of those processors are the exact same hardware internally. Just some are manufactured and have higher tolerance, so they clock those up and sell those for more. But then there's another chip on the wafer next to it in the manufacturing process that maybe when it's clocked up to 4 gigahertz, it starts producing errors. So they clock it down to 3 gigahertz and they sell it as a cheaper processor.
But they're all made the same way?
Yeah, internally, they're all exactly the same. Just sometimes some operate better at higher speeds and some don't, so that they sell them at different prices.
I did not know that.
They manufacture all of these processor cores on one wafer, and then they just test them all like, oh, we can sell these for more because these go faster. We'll sell these for cheaper because these can't go as fast.
That's bonkers. I had no idea.
Yeah. So in theory, I could see how this could happen. Maybe these processors, were clocked up to a speed where they started having errors. I don't know. I'm grabbing at straws there myself. That's my speculation. God, I keep getting distracted. Okay, back to the findings here. For the data spike failure mode, the built-in test equipment of the LTN 101 Air Data Inertial Reference Unit was not effective for air data parameters in detecting the problem, communicating appropriate fault information, and flagging affected data as invalid. So it was getting bad data and it wasn't flagging it. The Air Data Inertial Reference Unit manufacturer's failure mode affects analysis and other development processes for the LTN 101 Ataroo did not identify the data spike failure mode. Again, it's just seeing bad data, not flagging it. Although passengers are routinely reminded to keep their seatbelts fastened during a flight whenever they are seated, a significant number of passengers have not followed this advice. At the time of the first in-flight upset, more than 60 of the 303 passengers were seated without their seatbelts fastened. Fasten your seatbelts, people.
Yeah.
The large number of spurious warnings and caution messages that resulted from the anomalous air data inertial reference unit behavior created a significant amount of workload and distraction of the flight crew. So again, all these errors and alarms were distracting. Single event effects have the potential to adversely affect avionics systems that have not been specifically designed to be resilient to this hazard. There were no specific certification requirements for SEE, and until recently, there were no formal guidance material available for addressing SEE during the design process. The LTN 101 ADARU model had a demonstrated susceptibility to single event effects. The consideration of SEE during the design process was consistent with industry practice at the time the unit was developed, and the overall fault state of the ADARU were within the relevant design objectives. So they're kind of starting to hint here that they need to start accounting for single event effects, like one-off failures, one-off oddities, and they need to incorporate planning for this into future systems.
Yeah, just like better programming.
Right. These one-off things, you're going to have to start trying to think of them before they happen and hopefully account for them. Tests and analysis showed that the Air Data Inertial Reference Unit data spike failure mode was probably not triggered by a software bug, software corruption, hardware fault, physical environment factors, or from electromagnetic interference, which is frustrating because they basically say, yeah, it wasn't caused by anything that could have possibly caused it. So it's just kind of left as a question mark. Because normally you would think that the way they would word it is they would say, it was not caused by these things, but it was caused by this thing. This one just says, yeah, it wasn't caused by any of the possibilities. So there were some actions taken as a result of this. Airbus notified pilots that in the event of the nav IR fault, the flight crew are required to select the air data reference part of the relevant ADARU off, and then select the relevant inertial reference part of the relevant ADARU off. So this is probably what that other flight, that Qantas 71 did, where they saw this nav IR fault like 72 did, and then followed this procedure, so that way they were able to land back in Perth safely. Airbus introduced an interim modification to the flight control primary computer software standard that incorporated the modified monitoring and filtering of 5 parameters, including the AOA. So just some better filtering for potential bad data. Airbus reviewed the FCPC algorithms for processing each ADARU parameter on the A330, A340. The review examined data spikes that could potentially affect control of the aircraft's flight path. Airbus advised that it will apply lessons learned from this incident in the terms of the types of incorrect data patterns to be taken into account during future definition and modification. So again, they're just learning, like, hey, we see what bad data can look like. We're going to write better software in the future to account for potential bad data that looks like this.
Yeah, good.
Yeah, good. You want to hear that. The ADARU manufacturers advised that it examined a wide range of possible mechanisms within the LTN 101 CPU module that may have produced the air data reference spikes and was considering options to improve the robustness of some of the CPU module's processing activities. So again, I mean, the manufacturer's like, yeah, I mean, we'll look at making the CPU better, but who knows?
Yeah.
Airbus advised that it was evaluating the feasibility of measuring the seatbelt use rate of passengers on a sample of flights. The measurements would include various stages of flight and situations where the seatbelt sign is illuminated and also when it is not illuminated. Based on the results, the operator could then determine if additional specific communications or actions were warranted. So they just need to figure out, when are people wearing seatbelts? When aren't they? What can we do to get people to wear seatbelts more? They can tell people, listen to this podcast, wear your seatbelt. Yeah. We're saying it all the time. I feel like we've said this before in other episodes. If you're on a plane, wear the seatbelt. There's no reason not to.
We definitely have.
We've definitely mentioned this. And you're going to see the pictures. It'll tell you, why do you wear a seatbelt?
Why do they even have the seatbelt sign a thing if they want people to wear it more? Why do they tell people?
I think, if I have to speculate, I think it's a misunderstanding. I think that when the seatbelt sign is off, it means you can take your seatbelt off and stand up to go to the bathroom or to get something from an overhead bin if you want to, not take your seatbelt off. I think most people see that and they think, oh, take the seatbelt off.
Like, it's okay, doesn't matter.
Right. The sign should be more like, you can stand up and go to the bathroom and maybe stretch your legs if you want to, but if you're sitting down, wear your seatbelt.
Like a walking man or something instead of a seatbelt sign.
Yeah. Because the sign seems misleading, but, you know, when they do their safety briefings, they always tell you, if you're seated, please continue to wear your seatbelt. So I think it's just like, there's no effective way to communicate that in an easy to understand sign.
A walking man.
A walking man.
Or woman.
Or the walking person.
Yes.
In the aftermath of the accident, Qantas offered compensation to all passengers. The airline announced it would refund the cost of all travel on their itineraries covering the accident flight, offer a voucher equivalent to a return trip to London applicable to their class of travel, and pay for medical expenses arising from the accident. Further compensation claims would be considered on a case-by-case basis, with several passengers from the flight pursuing legal action against Qantas. One couple asserted they were wearing their seatbelts at the time of the incident and questioned Qantas's handling of the case. There was a flight attendant who was permanently injured. His name was Fuzzy Mayava, and he was advised not to take a settlement. He was offered 35,000 New Zealand dollars. Instead, his lawyers advised him to take part in a class action lawsuit against Airbus and Northrop Grumman. However, unfortunately, the case was dismissed, leaving that flight attendant and whoever was in that class action without any compensation.
Oh, man.
It sucks.
And
it's terrible.
Permanently disabled?
Yeah, he remains unable to work or drive a vehicle. But I understand where he's coming from, right? Like, if you're permanently disabled, I've seen interviews with him. He was in the back galley. He was preparing his meal he was going to eat. And when the plane dove, he went up. He says he hit his head on the top of the ceiling of the plane. He lost consciousness for a second or two, then came to consciousness, and then, was still kind of floating in the air. And then the plane corrected itself, and he slammed down and landed on his knees on the ground in the galley. And I can understand, it sounds like those, the injuries he sustained were probably serious to the point where he can't work. Imagine, getting that level of injury and then being offered 35,000 New Zealand dollars as your compensation. You think you'd be entitled to more than that.
Yeah.
Luckily, I can say the bright side was there were no fatalities. Everyone did survive, but some people were pretty seriously injured as a result of this. It was really violent inside the cabin of the plane. But that's Qantas 72, a more recent incident. But again, hopefully things were learned. There is still some mystery to it. I wish that we had a definitive. Aha! This was the smoking gun. This was the thing that caused it. Instead, it's this weird set of circumstances that led to this. But ultimately, lessons were learned. And like we said, it was applied almost immediately. Just 2 months later, Qantas Flight 71 had a similar incident, and they were able to recover just fine without any real serious issues. So I do want to say thank you to everyone for listening. Before we go, I do want to remind you, if you could do us a favor, we have a survey linked in our description. We're just trying to learn a little more about our listeners, about the things you like. If you could fill it out, just takes a minute or two. It would really do us a lot of good. Thank you so much. And again, that's in our description. And of course, follow us on social media. I'll be posting some of those images. We have, what do we have? Twitter, Instagram, Facebook. You can see all of those photos there.
Also, and we always tell people to share this with friends, post about it, the Black Box Down on Reddit. And like on the podcast subreddits or anywhere people, talk about podcasts or planes or anything like that. Just a specific place that I don't think we've mentioned before.
Speaking of Reddit, I follow, I'm in the aviation and the flying subreddits. And I forget which one it was. I think it was in the aviation subreddit. Someone posted a video of the rat. I believe it was a 777 rat operating. And I saw someone had just left a comment that said Black Box Down. It had gotten uploaded like 10 times. I thought it was really funny. So thank you. I don't remember who posted it, but I read it and I saw you post it. So thank you if you're the one who did that.
Yeah.
All right. Well, thanks for listening, everybody. We'll be back again next week.
Thanks.